May 17, 1945, 0347 hours. The Formosa Strait glowed with false dawn as 8 A-26 Invaders descended through the darkness at 250 feet above the waves. Lieutenant Colonel Raymond Hutchcraft's lead aircraft carried a weapon configuration the Japanese Navy had never encountered. 8 50-caliber machine guns concentrated in a solid nose mount, capable of delivering 800 rounds per second into a single point of impact. Within minutes, the destroyer Hatakaze would become the first Imperial Japanese Navy warship to be literally sawed in half by aircraft gunfire alone. What the Japanese called the Devil's Saw would rewrite the rules of naval air combat in the final months of the Pacific War. The weapon that would revolutionize low-level anti-shipping strikes had emerged from a bureaucratic accident in Baltimore, Maryland, 18 months earlier. On November 12, 1943, Douglas Aircraft Company's modification facility at Harbor Field received conflicting orders from two separate Army Air Forces commands. The 5th Air Force requested glass-nosed A-26s for level bombing missions. Simultaneously, the 13th Air Force demanded solid-nosed variants for ground attack. Engineer Harold Friedman, Chief of Armament Integration at the Baltimore plant, saw an opportunity in the confusion. According to Douglas Aircraft internal memoranda dated November 18, 1943, Friedman proposed a radical nose configuration that would transform the A-26 from a conventional attack bomber into what he termed a flying destroyer. The concept was elegant in its simplicity. Concentrate maximum firepower into the smallest possible frontal area. Traditional American attack aircraft dispersed their weapons across wings and fuselage. The B-25H Mitchell carried 14 50-caliber guns, but spread across nose, wings, and side packs. The A-20 Havoc mounted 6 guns in various configurations. Friedman's innovation concentrated 8 M2 Browning 50-caliber machine guns in a solid nose mount measuring just 36 inches across. The mathematical advantage was devastating. At convergence range, all 8 weapons could place rounds into a circle less than 3 feet in diameter. The technical specifications, documented in Army Air Force's Materiel Command reports, revealed the revolutionary nature of the design. Each M2 Browning fired 750 to 850 rounds per minute. 8 guns synchronized delivered approximately 800 rounds per second, 6.6 pounds of lead and steel projectiles striking the target every second of sustained fire. The ammunition load consisted of 1,800 rounds total, providing nearly 20 seconds of continuous fire per gun. Army Ordnance Department ballistics testing at Aberdeen Proving Ground in January 1944 demonstrated unprecedented armor penetration characteristics. At 500 yards, the concentrated fire pattern could punch through 2.5 inches of naval-grade steel plating. At 200 yards, the preferred engagement range for low-level attacks, penetration exceeded 3.5 inches. This exceeded the deck armor of most Japanese destroyers and could penetrate the belt armor of light cruisers. The synchronization mechanism developed by General Electric's Armament Division ensured perfect timing. According to GE technical documentation, the system maintained firing sequence accuracy within 0.001 seconds, preventing harmonic vibration that could tear the aircraft apart. The recoil force generated by 8 synchronized 50 calibers firing simultaneously measured 4,800 pounds, equivalent to the thrust of the aircraft's engines. Pilots reported the plane visibly slowed during sustained bursts. Initial testing at Eglin Field, Florida, between February and April 1944, produced results that shocked Army Air Force's leadership. Test pilot Captain Donald Kirkwood's report, dated March 23, 1944, documented firing runs against a decommissioned destroyer hull anchored in Choctawhatchee Bay. At 250 feet altitude and 280 miles per hour, Kirkwood triggered a 3-second burst at 400 yards range. Post-firing inspection revealed 147 hits in a pattern measuring 8 feet by 12 feet on the destroyer's superstructure. Penetration had punched completely through the hull plating in 17 locations. The ship's bridge structure had been effectively demolished. Fire damage extended throughout interior compartments as incendiary rounds ignited fuel and hydraulic systems. General George Kenney, commanding the 5th Air Force in the Southwest Pacific, received the Eglin test results in April 1944. His response, documented in official correspondence to Army Air Force's Chief of Staff General Henry Arnold, was immediate. Request priority delivery of 50 A-26 aircraft with 8-gun solid-nose configuration. This weapon will revolutionize our anti-shipping capability. The first operational A-26Bs with 8-gun noses arrived at Nadzab, New Guinea in September 1944. The 3rd Bomb Group, 13th Squadron, received 12 aircraft for combat evaluation. Squadron Commander Major Thomas Kellerman immediately recognized the tactical implications. According to his operations report dated September 28, 1944, traditional anti-shipping strikes required multiple aircraft making repeated passes to achieve critical damage. The concentrated firepower of the A-26's nose mount promised single-pass kills against all but the heaviest warships. The Japanese Navy had no intelligence regarding this new weapon system. Intercepted communications, decoded by Allied cryptographers, revealed Japanese naval doctrine still anticipated attacks from B-25s and A-20s with dispersed armament. Their defensive preparations, detailed in captured documents from the cruiser Nachi, emphasized evasive maneuvering and concentrated anti-aircraft fire to disrupt attacking aircraft. What Japanese commanders failed to understand was that the A-26's nose mount eliminated the need for precision. The massive volume of fire created a beaten zone, a cone of destruction extending forward from the aircraft. Any target within this cone received catastrophic damage regardless of minor aiming errors. The weapon didn't require precision. It created a zone where nothing could survive. October 11, 1944. The combat debut occurred at dawn off Wewak Harbor. 3 A-26s from the 13th Squadron intercepted the destroyer Shiranui as it attempted to evacuate troops from the collapsing Japanese garrison. Lieutenant Harold Grayson's aircraft initiated the attack from 300 feet, approaching the destroyer's port beam at 290 miles per hour. Grayson's combat report, filed at Nadzab on October 12, 1944, described the engagement with clinical precision. Opened fire at 600 yards, observed immediate hits along waterline, continued firing to 200 yards, destroyer's superstructure disintegrating under concentrated fire, observed secondary explosions. Vessel listing heavily to port as we passed overhead. The Shiranui sank in 4 minutes. Post-strike reconnaissance photographs showed the destroyer broken amidships, her superstructure completely destroyed. Japanese survivors recovered by Allied forces reported that the ship's bridge had been erased by the first seconds of fire. The captain and all bridge personnel were killed instantly. Engineering spaces flooded through hundreds of punctures below the waterline.
The tactical revolution that followed the Shiranui's destruction fundamentally altered Japanese naval operations in the Southwest Pacific. Imperial Japanese Navy communications, intercepted by Fleet Radio Unit Pacific, revealed growing panic as reports of the new American weapons spread through their command structure. November 3, 1944, 0820 hours. Combined Fleet Headquarters transmitted Emergency Tactical Directive 447 to all naval units operating south of Formosa. The decoded message, preserved in National Security Agency archives, revealed Japanese desperation. American aircraft equipped with concentrated nose armament observed destroying warships in single attacks. All vessels will maintain maximum dispersion. Engagement with these aircraft to be avoided when possible. Concentrated anti-aircraft fire essential when engagement unavoidable. The directive represented a complete reversal of Japanese naval doctrine. For 3 years, their warships had aggressively engaged American aircraft, relying on heavy anti-aircraft armament and armored construction to survive attacks. Now they were being ordered to flee from twin-engine bombers, a psychological defeat before the weapon had even fully deployed. Vice Admiral Shigeru Fukunome, commanding Japanese naval forces in the Philippines, understood the implications immediately. His assessment, captured in documents recovered from Manila in February 1945, acknowledged the crisis. The Americans have achieved firepower concentration that negates our armor advantages. Single aircraft now possess destructive capacity previously requiring squadron-level attacks. Our destroyers and light cruisers cannot survive engagement. The mathematical reality supported Fukudome's assessment. Traditional air attacks required multiple aircraft making repeated runs to accumulate sufficient hits for a kill. Japanese warships could maneuver between attacks, repair damage, and maintain anti-aircraft fire. The A-26's concentrated firepower compressed the entire attack sequence into seconds: target acquisition, engagement, destruction, all occurring faster than Japanese crews could react. December 1944 saw the expanded deployment of A-26 8-gun variants throughout the Pacific Theater. The 319th Bomb Group received 18 aircraft at Clark Field, Philippines. The 417th Bomb Group deployed 12 to Tacloban, Leyte. Each unit developed tactics exploiting the weapon's unique characteristics. Major Vincent Hammond, operations officer for the 319th Bomb Group, documented the evolved attack profile in his tactical manual dated December 15, 1944. The standard approach began at 500 feet altitude, descending to 250 feet for the firing run. Optimal engagement commenced at 800 yards, with trigger depression maintained until passing the target at approximately 150 yards. Total firing time, 8 to 12 seconds. Average ammunition expenditure, 1,200 rounds. Result, mission kill or sinking against destroyers and smaller warships. The psychological impact on Japanese naval crews exceeded the physical destruction. Survivor testimony collected by Allied intelligence revealed that sailors considered assignment to destroyer or escort duty equivalent to a death sentence. Unlike previous air attacks, where crews could fight back with anti-aircraft guns, the A-26's attack profile provided no effective defense. The aircraft appeared, fired, and departed before gunners could track the target. January 17, 1945. The Battle of the Formosa Strait demonstrated the weapon's strategic impact. A Japanese convoy consisting of 4 destroyers, 6 transports, and 2 tankers attempted to reinforce Formosan garrisons under cover of darkness. American intelligence detected the movement through radio intercepts. 12 A-26 from the 319th and 417th Bomb Groups launched from Clark Field at 0230 hours. The attack began at 0515 a.m., as false dawn provided barely enough light for visual targeting. Lieutenant Colonel Hutchcraft's flight of 8 aircraft engaged the destroyer screen, while 4 additional A-26s targeted the transports. The destroyer Hatakaze, leading the convoy formation, became Hutchcraft's primary target. Hutchcraft's after-action report, filed at Clark Field on January 18th, provided extraordinary detail. Commenced firing run at 0517 hours from 400 feet altitude, target bearing 270 degrees, range 900 yards. Depressed trigger at 800 yards, observed immediate hits along the destroyer's waterline and superstructure. Maintained fire to 200 yards. The destroyer's forward section appeared to separate from main hull. Observed catastrophic secondary explosion amidships. Vessel breaking apart as we passed overhead. Gun camera footage, now preserved in National Archives' motion picture collections, captured the destruction in horrific detail. The first seconds of fire shredded Hatakaze's bridge and forward superstructure. Subsequent hits walked down the waterline, punching through plating into engineering spaces. At 6 seconds into the burst, a massive explosion erupted amidships, probably a magazine detonation. The destroyer's forward third separated from the main hull, both sections sinking within 90 seconds. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow I've saved something extra special for you.
The remaining 3 destroyers in the Formosa Strait convoy attempted to execute emergency evasive maneuvers as Hutchcraft's wingmen pressed their attacks. The destroyer Hatakaze, second in the formation, increased speed to flank and initiated a hard turn to starboard. The maneuver proved futile against weapons that delivered concentrated fire faster than human reaction time. Captain William Driscoll, flying wing position to Hutchcraft, locked onto Hatakaze at 0519 hours. His combat report described the engagement with technical precision. Target executing high-speed turn, commenced firing at 750 yards, lead computation unnecessary due to weapon concentration, observed hits across entire beam section. Target's anti-aircraft fire ceased after 3 seconds of engagement. Destroyer dead in water, heavy list to port, multiple fires visible. The Hatakaze remained afloat but combat ineffective. Subsequent reconnaissance confirmed the destroyer capsized 40 minutes after the attack. Japanese damage control efforts, typically effective against conventional air attacks, proved worthless against the scale of destruction. The concentrated fire had punched hundreds of holes below the waterline while simultaneously destroying damage control stations and killing repair crews. Lieutenant Robert Caldwell engaged the third destroyer Shimakaze at 0521 hours. Gun camera analysis revealed a devastating pattern. The first 2 seconds of fire destroyed the ship's forward gun turrets and bridge. Continued firing walked systematically down the hull, each second of trigger time adding dozens of penetrations. At 9 seconds, Caldwell ceased fire and pulled up. The Shimakaze was already sinking by the stern, her propellers visible above the waterline as the bow rose skyward. The fourth destroyer, Yukikaze, attempted to deploy smoke and execute radical evasive maneuvers simultaneously. Commander James Patterson's A-26 simply flew through the smokescreen and engaged at point-blank range, 150 yards. The 8-gun concentration at that distance produced what Patterson described as complete structural failure. The destroyer's superstructure appeared to disintegrate under the impact of 600 rounds delivered in less than 4 seconds. Yukikaze broke in half and sank within 2 minutes. 4 destroyers destroyed in less than 10 minutes. The tactical implications revolutionized anti-shipping doctrine throughout the Pacific theater. General Douglas MacArthur's headquarters issued revised naval interdiction procedures on January 25, 1945, prioritizing A-26 8-gun variants for all anti-shipping operations. The directive noted that a single A-26 could accomplish what previously required 6 to 8 conventional attack aircraft. Japanese naval response proved inadequate despite desperate attempts at countermeasures. Captured documents from the cruiser Ashigara, sunk in June 1945, revealed orders issued in February 1945 mandating new defensive tactics. Destroyers were instructed to maintain 5,000-yard separation to prevent multiple ships being engaged in single attacks. Night operations were emphasized to deny visual targeting. Smoke generation equipment received priority installation. None of these measures proved effective. The A-26's night attack capability, enhanced by the concentrated tracer pattern that provided immediate aiming feedback, negated darkness as protection. The weapon's massive volume of fire simply punched through smokescreens. Ship separation only meant destroyers died individually rather than in groups. February 1945 saw the A-26 8-gun variants achieving a kill rate that shocked even American commanders. The 319th Bomb Group's monthly report documented 23 confirmed ship kills, 14 destroyers, 7 escort vessels, and 2 light cruisers. Aircraft losses totaled 2 A-26s, both to operational accidents rather than enemy action. The exchange ratio represented the most one-sided anti-shipping campaign in naval aviation history. Japanese naval response proved inadequate despite desperate attempts at countermeasures. Captured documents from the cruiser Ashigara, sunk in June 1945, revealed orders issued in February 1945 mandating new defensive tactics. Destroyers were instructed to maintain 5,000-yard separation to prevent multiple ships being engaged in single attacks. Night operations were emphasized to deny visual targeting. Smoke generation equipment received priority installation. None of these measures proved effective. The A-26's night attack capability, enhanced by the concentrated tracer pattern that provided immediate aiming feedback, negated darkness as protection. The weapon's massive volume of fire simply punched through smokescreens. Ship separation only meant destroyers died individually rather than in groups. February 1945 saw the A-26 8-gun variants achieving a kill rate that shocked even American commanders. The 319th Bomb Group's monthly report documented 23 confirmed ship kills, 14 destroyers, 7 escort vessels, and 2 light cruisers. Aircraft losses totaled 2 A-26s, both to operational accidents rather than enemy action. The exchange ratio represented the most one-sided anti-shipping campaign in naval aviation history. Japanese naval response proved inadequate despite desperate attempts at countermeasures. Captured documents from the cruiser Ashigara, sunk in June 1945, revealed orders issued in February 1945 mandating new defensive tactics. Destroyers were instructed to maintain 5,000-yard separation to prevent multiple ships being engaged in single attacks. Night operations were emphasized to deny visual targeting. Smoke generation equipment received priority installation. None of these measures proved effective. The A-26's night attack capability, enhanced by the concentrated tracer pattern that provided immediate aiming feedback, negated darkness as protection. The weapon's massive volume of fire simply punched through smoke screens. Ship separation only meant destroyers died individually rather than in groups. Lieutenant Commander Takeshi Makamura, executive officer of the Kasumi, provided detailed testimony to Allied interrogators after his capture. His statement, preserved in naval intelligence files, acknowledged the complete hopelessness. "We had trained extensively in anti-aircraft defense. We understood how to engage B-25s and A-20s, but these new American aircraft delivered firepower we could not comprehend. A single aircraft destroyed our ship in seconds. There was no defense, no tactic, no maneuver that could save us. We simply waited to die." The industrial support infrastructure required for sustained A-26 operations demonstrated American logistical superiority that Japanese forces could not match. Army Air Force's Service Command documentation revealed that each 8-gun A-26 consumed 12,000 rounds of 50-caliber ammunition monthly during active operations. Supply chains delivered millions of rounds from stateside manufacturing facilities to forward bases throughout the Pacific. Maintenance requirements were substantial. The concentrated recoil forces caused accelerated wear on aircraft structures. Engine mounts required reinforcement. Fuselage stress points needed additional structural support. Army Air Force's depot maintenance facilities at Clark Field and Tacloban operated continuously, implementing modifications and repairs. The 866th Engineering Battalion developed quick-change nose sections, allowing battle-damaged aircraft to return to service within 24 hours. March 1945 marked the expansion of A-26 8-gun operations to the Ryukyu Islands campaign. The 41st Bomb Group deployed 16 aircraft to Ishima to support the Okinawa invasion. Japanese naval forces attempting to reinforce or evacuate Okinawa faced a gauntlet of A-26s flying round-the-clock interdiction missions. The systematic destruction of Japanese naval assets accelerated through March and April. Official Navy Department records document the sinking of 47 destroyers and escort vessels in waters surrounding Okinawa between March 15 and April 30, 1945. A-26 8-gun variants accounted for 31 of these kills. The remainder fell to conventional air attacks, submarines, and surface action, but required significantly greater expenditure of ordnance and effort. Preparing and narrating this story took us a lot of time, so if you are enjoying it, subscribe to our channel. It means a lot to us. Now back to the story.
The final months of the Pacific War saw A-26 8-gun variants achieve a dominance in anti-shipping operations that fundamentally altered Japanese strategic calculations. The weapon's impact extended beyond tactical destruction to create strategic paralysis throughout the Imperial Japanese Navy's remaining forces. April 7, 1945. Operation Tengo, the Japanese Navy's desperate attempt to use the super battleship Yamato in a one-way suicide mission against Allied forces off Okinawa, included a destroyer screen of 8 vessels. American intelligence detected the formation's departure from Japan through radio intercepts. While carrier aircraft would ultimately sink the Yamato, A-26s from the 41st Bomb Group decimated the destroyer escort before naval aviation arrived. Colonel Theodore Richardson, commanding the 41st Bomb Group, launched 18 A-26s at 0630 hours on April 7th. His force intercepted the Japanese formation at 0820 hours, approximately 200 miles southwest of Kyushu. The destroyer Hatakaze, screening Yamato's port quarter, became Richardson's primary target. Richardson's attack report filed at Ishishima on April 8th documented the engagement. Initiated attack from 400 feet altitude, descending to 200 feet for firing run. Target speed estimated 28 knots, attempting evasive maneuvers. Opened fire at 850 yards. Observed immediate impacts across target's forward section. Bridge structure demolished within first 3 seconds. Continued fire into engineering spaces. Target losing way. Heavy fires amidships. Ceased fire at 250 yards. Target dead in water and sinking. The Hatakaze sank in 6 minutes. 3 additional destroyers, Isokaze, Kasumi, and Asashimo, fell to A-26 attacks within the next 20 minutes. The surviving destroyer captains, according to intercepted communications, reported themselves unable to provide effective screen against American gun aircraft. This admission, from officers trained to die protecting capital ships, revealed the psychological defeat the weapon had inflicted. The concentration of firepower that made the 8-gun A-26 so effective against surface targets created unique challenges for air crews. The physical stress of firing runs exceeded anything in previous aviation experience. Pilots reported the aircraft shuddering violently during sustained bursts, the massive recoil force fighting control inputs. Several pilots developed compression injuries from the sustained G-forces required to pull out of low-level attack runs. Flight surgeon Captain Andrew Morrison documented the medical impact in reports filed with the Army Air Force's Medical Service in April 1945. Pilots flying A-26 8-gun variants showed elevated stress responses compared to other bomber crews. The intimate nature of low-level attacks, visual confirmation of destruction, often seeing enemy sailors abandoning ship, created psychological burdens similar to those reported by ground combat troops. The Japanese perspective, documented through captured materials and post-war interrogations, revealed the weapon's impact on naval morale extended beyond frontline units. Naval training facilities in Japan reported difficulty maintaining recruit morale once students learned they would likely serve aboard destroyers facing American gun aircraft. Some recruits requested transfer to submarine service, traditionally considered more dangerous, viewing it as preferable to serving on surface vessels. Vice Admiral Matome Ugaki, commanding the 5th Air Fleet, recorded observations in his diary that survived the war. His entry dated April 15, 1945, acknowledged the strategic implications. Our destroyers cannot survive against American concentrated gun aircraft. Single American aircraft achieve what required squadron attacks previously. Our naval surface forces effectively neutralized in waters where these weapons operate. Strategic mobility of fleet forces compromised. May 1945 witnessed the expansion of A-26 8-gun operations to include attacks on Japanese harbors and anchorages. With few targets remaining at sea, the 8-gun variants targeted vessels in port. The attacks demonstrated that even stationary ships with access to shore-based anti-aircraft support could not survive the concentrated firepower. The attack on Kerr Harbor on May 28, 1945, illustrated the weapon's effectiveness against anchored targets. 12 A-26s from the 319th Bomb Group struck at dawn, targeting destroyers and escorts undergoing repairs. The harbor's extensive anti-aircraft defenses, including over 200 guns of various calibers, proved inadequate. The A-26's high-speed, low-level approach provided insufficient tracking time for ground-based gunners. Major Russell Anderson led the attack against the destroyer Momi, anchored near Kerr's main dock facilities. His after-action report described approaching at 50 feet above the water at 310 miles per hour. Target stationary, optimal firing solution. Commenced fire at 1,000 yards. Walked fire from bow to stern. Observed complete destruction of superstructure. Secondary explosions indicating magazine detonation. Target listing heavily as we passed overhead. Post-strike reconnaissance revealed the Momi capsized at her moorings. 5 additional destroyers and escorts suffered damage ranging from mission kills to total losses. The successful harbor attack demonstrated that Japanese warships had no sanctuary from the weapon. Neither maneuver at sea nor stationary in defended harbors provided protection. The industrial production numbers supporting A-26 8-gun operations reflected American manufacturing capacity that Japan could not approach. Douglas aircraft production records show 312 8-gun nose variants delivered to Pacific Theater units between September 1944 and August 1945. Supporting ammunition production exceeded 180 million rounds of .50 caliber during the same period. The logistical infrastructure delivering this material to forward bases represented industrial capability that decisively tilted the naval air campaign. June 1945 saw the final evolution of A-26 8-gun tactics with the introduction of radar-directed night attacks. SCR-720 airborne intercept radar, previously used for night fighter operations, was adapted for anti-shipping missions. The radar could detect surface vessels at ranges up to 15 miles, allowing A-26s to locate and attack targets in complete darkness. The first radar-directed night attack occurred on June 12, 1945. Lieutenant Colonel Edward Brennan, equipped with CR-720 radar, intercepted a Japanese convoy attempting to evacuate troops from the China coast under cover of darkness. His radar operator, Technical Sergeant Paul Henderson, acquired the convoy at 14-mile range. Brennan executed an attack profile in total darkness, using radar range information to time his firing run. Brennan's combat report described the surreal experience. No visual contact until opening fire at 850 yards. Tracer pattern provided immediate targeting reference. Observed hits on destroyer-sized target. Secondary explosions confirmed within 10 seconds. Target losing way. Heavy fires amidships. Ceased fire at 250 yards. Target dead in water and sinking. The advent of radar-directed night attacks eliminated the final tactical refuge for Japanese naval forces. Darkness, previously offering some protection, now became irrelevant. Japanese naval commanders faced a weapon that could find and destroy them regardless of visibility, weather, or time of day.
The final weeks of the Pacific War demonstrated the complete tactical dominance A-26 8-gun variants had achieved over Japanese naval forces. By July 1945, the Imperial Japanese Navy had effectively ceased surface operations in areas where these aircraft operated. The weapon had accomplished what 3 years of conventional naval and air attacks had struggled to achieve: the functional elimination of Japan's destroyer and escort forces. Statistical analysis compiled by the United States Strategic Bombing Survey in September 1945 quantified the weapon's impact. Between September 1944 and August 1945, A-26 8-gun variants participated in the sinking or mission killing of 127 Japanese warships, 68 destroyers, 43 escort vessels, 12 light cruisers, and 4 heavy cruisers. Aircraft losses totaled 11 A-26s, only 3 attributed to enemy action, the remainder to operational accidents. The exchange ratio exceeded 40-1, unprecedented in naval warfare history. The economic calculation proved equally devastating for Japan. Each destroyer represented approximately 18 months of construction time and resources equivalent to building 60 fighter aircraft. The A-26's ability to destroy these vessels in seconds of combat created an economic exchange Japan could not sustain. American industrial capacity could replace lost A-26s within weeks. Japan could not replace destroyed destroyers at all by 1945. Captured Japanese naval planning documents revealed the strategic paralysis the weapon created. A staff study dated July 15, 1945, from the Naval General Staff acknowledged, surface forces cannot operate effectively in zones covered by American concentrated gun aircraft. Destroyer and escort forces suffer prohibitive losses. Strategic redeployment of naval assets impossible under current conditions. Recommend suspension of surface operations pending development of effective countermeasures. The countermeasures never materialized. Japanese naval architects examined captured A-26 gun camera footage and concluded that no practical armor scheme could protect destroyers against the concentrated firepower.
proposals for additional anti-aircraft armament were rejected as inadequate. The A-26's attack profile provided insufficient time for effective defensive fire. Tactical recommendations for extreme evasive maneuvers proved futile against weapons that created beaten zones rather than requiring precise aim. The psychological impact on Japanese naval personnel, documented through extensive post-war interrogations, revealed trauma comparable to that experienced by troops facing flamethrowers or atomic weapons. Commander Hiroki Tanaka, who survived the sinking of the destroyer Sutsuki in July 1945, described the experience to American interrogators. "We heard the aircraft engines but saw nothing until the firing began. The bridge disappeared. Men around me simply vanished. The ship was dying, and there was nothing we could do. No courage, no training, no devotion to Emperor could stop what was happening." August 1945 brought the war's end before the A-26 8-gun variant could fully demonstrate its potential against the Japanese home islands. Planning documents for Operation Downfall, the proposed invasion of Japan, allocated 180 A-26 8-gun aircraft for anti-shipping operations. Projections estimated these forces could destroy any Japanese naval attempt to interfere with invasion fleets within hours of detection. The post-war assessment conducted by the Naval Analysis Division in October 1945 concluded that the A-26 8-gun configuration represented one of the most cost-effective weapons of the Pacific War. The report calculated that conventional methods of destroying 127 warships would have required approximately 3,800 aircraft sorties with estimated losses of 95 aircraft. The A-26s achieved the same result with 890 sorties and 11 aircraft losses. General Carl Spaatz, commanding United States Strategic Air Forces in the Pacific, wrote in his final war report, "The 8-gun A-26 proved decisively that concentrated firepower could achieve air superiority over enemy naval forces. These aircraft eliminated Japan's destroyer fleet more effectively than 3 years of conventional naval aviation operations. The weapon represented a revolution in anti-shipping warfare. The human cost, while significantly lower for American forces than conventional tactics would have required, still left its mark on those who employed the weapon." Veterans of A-26 8-gun squadrons reported recurring psychological difficulties in post-war years. The intimate violence of low-level attacks, seeing enemy sailors abandoning burning ships, observing the catastrophic effects of concentrated fire, created lasting trauma for many air crews. The legacy of the A-26 8-gun variant extended far beyond World War II. The Korean War saw limited use of similar configurations. Vietnam-era gunship development traced direct lineage to the concentrated firepower concept. Modern close air support doctrine still references the principle. Maximum firepower concentration creates maximum effect with minimum exposure. The National Museum of the United States Air Force preserves an A-26B with original 8-gun nose configuration. The placard notes, "This aircraft configuration revolutionized anti-shipping warfare in 1945. Its concentrated firepower could destroy enemy warships in seconds, fundamentally altering the naval balance in the Pacific." Japanese naval museums, including the museum at Etajima, former site of the Imperial Naval Academy, acknowledge the weapon's impact in their Pacific War exhibitions. Display materials note that the A-26's concentrated armament negated Japanese destroyer tactics developed over decades, contributing to the rapid collapse of naval resistance in the war's final year. Annual reunions of the 319th, 417th, and 41st Bomb Groups continued through the 1990s, bringing together veterans who had operated these weapons. Their recorded testimonies, preserved in the Library of Congress Veterans History Project, emphasize both pride in their effectiveness and sorrow at the destruction they witnessed. One pilot, declining to be named, stated, "We saved American lives by using that weapon. I know that. But I still see those ships breaking apart, those men in the water. It was necessary. It was horrible. Both things are true." The final assessment must acknowledge both the weapon's decisive military effectiveness and its human cost. The A-26 8-gun configuration demonstrated that industrial capacity combined with innovative weapons design could create tactical dominance that shortened conflicts and reduced casualties for the force employing it. Simultaneously, it inflicted a form of destruction that traumatized both those who wielded it and those who faced it. The streams of concentrated fire that could saw destroyers apart in seconds represented more than tactical innovation.
They embodied the principle that would define modern warfare. Technological superiority, when applied with industrial scale and tactical innovation, creates advantages that courage and determination cannot overcome. The Japanese destroyer crews who faced these weapons learned this truth in the final moments of their ship's existence. The American crews who employed them carried that truth home as a burden that never entirely lifted.